back. So today we're going to be covering what OSPF is. So the goals for today are to understand what OSPF is. We'll also get hands-on practice with Cisco Packet Tracer. So we'll be doing some labbing and configuring just OSPF on Cisco Packet Tracer so you can get just a view of what that looks like. So what is OSPF? OSPF is an interior gateway protocol, IGP, and it's a dynamic link state routing protocol. How it works: routers exchange link state advertisements to build a complete map of the network topology, then using the shortest path algorithm to calculate the best path to each destination. So what is a link state advertisement? So it's a message used by OSPF routers to share information about their links and network connections. It contains details about a router's interfaces, neighbors, and network status, and is sent to other routers within the same OSPF area. It'll use these link state advertisements to build a complete network map called a link state database, and it helps routers find the best path using the shortest path algorithm. So what are some of the OSPF packet types, right? So we have the hello packet, and the hello packet type is used to discover and maintain neighbor relationships. It'll be sent continuously, and it'll contain the router ID, hello dead interval, and the area ID. The next packet type is database description. So this basically summarizes the link state database, and it's exchanged during the initial neighbor adjacency to compare databases. So once a router creates a neighbor, it will compare its databases to each other. So the next type is a link state request. After the database description is exchanged, routers request specific link state advertisement they're missing from the neighbor. Say, for example, router A has, this information about this neighbor, but router B doesn't, then it'll request that information from router A, right? Router B will request information from router A saying, hey, I don't have this information about, this neighbor. Can you share that information with me? And then the next packet type is a link state update, which contains one or more link state advertisements. This is the actual routing information being flooded through the network. And the link state acknowledgement, the last packet type, is acknowledging the receipt of the link state updates, ensuring reliable link state advertisement flooding. So once it receives the updates, it basically acknowledges saying, hey, I received your updates, I received the updates, and that essentially just lets the other router know, okay, my job here is done. The router has acknowledged that it's received the link state information. So what are the OSPF neighbor states? So you have down, which basically means that there has been no hello packets received. Init, which is hello packets have been received, but there's no bidirectional communication yet between the routers. And two-way is when bidirectional communication has been established. So the designated router and the backup designated router are elected here. And in XStart, that's when the database description exchange begin. So they start, sharing database information with each other. In the exchange, the database description packets are now fully exchanged. And in the loading, the link state requests, link state updates, exchange is in progress. So this is where, any information that is shared between the routers in regards to other neighbors that they might have. And then it'll finally reach full. And in full, this is when they are fully adjacent and have identical link state databases. So if there was any information in router A about a neighbor that router B did not have, in the full state, they will have fully synchronized link state databases, meaning that their link state databases will look the same because router A has sent all of its link state advertisements about its neighbors to router B, and router B has done the same thing for router A. So now they should have the same link state databases. So how does OSPF work, right? So it first needs to discover its neighbors, right? So this is done by sending hello packets to establish an adjacency. And Next thing is it'll flood these link state advertisements. So essentially what it looks like is router A shares its information with router B, and then router B will share that information with its neighbor, and so on and so on. So essentially you just have router sharing link state advertisements with its neighbors. Since router A doesn't have router C as a neighbor, but router B does, router B is the one that's sharing that link state advertisement to router C. And then after that's done, it'll create a link state database. So because now all the routers have information about each other's neighbors, now it starts to create the link state database, right? So now all of them will have the same database, router A, router B, and router C. And then it will run SPF, so it'll calculate the shortest path tree to destinations, right? And then it'll go ahead and populate the best paths into the routing table. So OSPF areas, so networks are divided into areas. Area 0 connects all other areas. Areas reduce, let's say, flooding and SPF calculations, which improves scalability. So you can create essentially areas within OSPF. So you can have an area 0, you can have an area 1, 2, or whatever you would like. And as it mentions, it's good to improve scalability. So how do neighbor states work with packet types, right? So during the OSPF state of down and init, the main packet type that's being used is hello, right? To essentially discover what its neighbors are. And then from init to two-way, there's still hello packets that are being sent. And this just creates that bidirectional communication. During the two-way to X-start, that's when we now start to see the database description packets. And this is where the database exchange starts to happen, right? In X-start, exchange, still database description packets are being shared. And this is when the LSDB summary exchange happens. In the exchange to loading, this is where the link state requests, link state updates, link state acknowledgements, packet types are being used. And this is essentially the request missing information. So as I mentioned, let's say router C doesn't have information about router B's neighbors, which is router A. This is where router C, this is where, we'll have the link state request and updates made so that router C has the information about router B's neighbors. And then once at full, for going from loading to full, this is when there's acknowledgement that all the link state advertisements and updates have been received by each router. So there's essentially all the routers have the same link state database synced up. So configuring OSPF. So essentially here we have the commands, right? So to enable OSPF on the router, you do router OSPF and then the process ID. And then you want to also go ahead and define the networks. Essentially what defining the networks means is you just want to go ahead and say, okay, what are the networks that I am directly connected to, right? As a router, what networks are directly connected to me. So you will go ahead and put the network and the IP address of it and a wildcard mask and then the area ID, right? So it's also optional to set a router ID. You can go ahead and set a router ID, which you will set as an IP address. And this essentially, the router ID is essentially used to just identify the router, right? You'll see that once we go ahead and configure, if we set a router ID, you'll see it on the OSPF just neighbor information once we verify just that, once we've configured OSPF. So what is the process ID? The process ID is a number used to identify an OSPF process running on a router. It is locally significant, meaning it only matters on the router where it is configured. Right? Two routers do not need to use the same process ID to become neighbors. A router can run multiple OSPF processes using different process IDs. And then the area ID. The area ID is used to divide an OSPF network into smaller sections called areas. It helps organize routers and reduce routing overhead. All routers in the same area must use the same area ID to form neighbors. So area 0, the backbone area, is a central area that connects all other areas. Okay. And these are some of the configurations that we'll be using to check OSPF neighbor adjacencies, check the OSPF process information, and to view the routing table. So show IP OSPF neighbor will show us just neighbor adjacencies, show IP OSPF will show us the process information, and then we'll be able to take a look at the routing table with show IP route. And then another command will be show IP OSPF database, which will be able to see the database for each router, which will show just its neighbors. So let's go ahead and jump over to Cisco Packet Tracer. So let's go ahead and start. I've already configured here the IP addresses to the interfaces. So here we have a 10.0.12 network with the subnet mask of /24. Here we have a 10.0.14 network with the subnet mask of /24. The 10.0.15 network with the subnet mask of /24. The 10.0.36 network with the /24, and the 10.0.24.0 network with the /24. Let's go into router 0. So we'll enable config terminal, and we want to go ahead and create. So we'll have this process ID just be 1. And then when we jump on here, we want to go ahead and set the network. So remember, router 0 is directly connected to the 10.0.12.0 network. We'll put our wildcard mask, and then we'll set the area. Is 10.0.24.0. Okay. So, for example, if I were to OSPF neighbor, we're not going to see anything, right? There's nothing on there. Same thing if I were to try and look at the routing table, right? There's nothing yet because I haven't configured OSPF on other routers, right? So let's do it now for router 2. So sorry, for router 1. Okay, config. Now that works. So this has zero and then network 10.0.12 and then also the 14.0 network. Right. Okay, so you see now there's essentially process ID, process 1, and it's created a neighbor, right? 10.0.24.1 on gigabit Ethernet 000. So which is this router, right? And that's the 10.0.24.1 is using, that's essentially what it's selecting as the router ID for it. So if you don't set up a router ID, it'll essentially populate a router ID for you, and it selects the highest IP. So let me go ahead and finish. So I was setting up the wildcard mask. Okay, perfect. So let's go ahead and look at neighbor. Spell something, OSPF, sorry, neighbor. Right, so you can see its neighbor ID, and it has a state of full, right? And then the address. So this is this router here, right? Router 1. Okay. And now let's go here, configure it, and let's go ahead, and then this one has router 2 has network 10.0.14.0. And then work. And then same thing, you'll see it established a neighbor with this router, right? Okay, 10, sorry, 15.0.0.0.0 to area 0, right? So do show IP OSPF neighbor. And you can see this is, it shows the neighbor ID here, right? And I want to see now, let's take a look at the database. So you see here in the database how we're able to see the neighbors. So we have the 10.12, 14.1, right? In router 2, once we ran that do show IP OSPF database command, right? Okay, now let's see the last router. OSPF 1. I keep misspelling OSPF. Okay, network 10.0.15.0.0.0 area 0, and then you'll see that it'll go from down to full in a second. Usually happens when I start typing. It takes a second for it to, there you go. Let me just, let me add the second network, which will be 36.0.0.0 area 0. Okay. And then we see IP OSPF neighbor, right? It'll show us that this is its neighbor, right? It's its neighbor, and then we can look at the full database. So now all the routers have the same database. So if I go from router 3 to router 2, we'll see the same information for neighbors, right? This is router 3. Okay, let's look at that. Right, we see all of its neighbors. We see its neighbors, right? So router 2 has these neighbors, right? 10.0.12, 10.0.14, and 10.0.15. Okay, and then let's go ahead and configure the last router, OSPF, so router OSPF. Let's go ahead and add the networks. So it's networks 0.24.0, wildcard math, area 0, so these all belong to the same area. And then I'll add this last network, and then you'll see that from that last neighbor created, right? So now we went from loading to full. Okay, area 0. So now let's go ahead and show neighbor, right? So here we'll have two neighbors, right? Which is this 24.1 and then this 36.1, right? So that's its two neighbors. And then as you saw, it just finished creating this neighbor here, the 10.0.36.1 went from loading to full. It was on the X start state. Now it's in the full state. So let's go ahead and now see the database. So you can see, right, router 4, we can see all the neighbors that it has, right? So 12, 14, 15, right? 24, 36, right? So all of its neighbors. And okay, I want to show you now a ping. So I'm going to end this here. And router 0. So before we do the ping, actually, I want to show you what the routing table looks like. Show IP route. So here in the routing table, we're able to see the routes of OSPF, right? So all these that have O, right, OSPF, the 14 network, 15 network, 36 network, right, for router 0. 14, 15, 36, and then it shows you also which networks is directly connected to, which is the 12 and the O. Sorry, the 12 and the 24. But for these, right, these networks were created through OSPF. So now let's go ahead and ping. So I want to ping router 3. So we're going to ping that, and also on simulation mode. Let's close that. Play this. Okay. So you see, goes on, sends that, returns it. Right, as you can see, we didn't have to manually right, since OSPF is a dynamic routing protocol, we didn't manually have to create the path to this router, right, to this network 10.0.36, right? OSPF handles that. So OSPF is able to create a database for us that says, hey, I might not have a neighbor. This might not be my neighbor, but my neighbor, router 4, it is its neighbor, right? So all of these have the same link state database. So for example, if I wanted to now ping, router 2, I'll be able to as well. And like I'm mentioning, I didn't manually have to create a route in the routing table that, says in order for me to reach 10.0.36, I will have to go through 10.0.24 network, right? And the next hop address would be a 10.0.24.2. All of this is dynamically done through OSPF, right? And we'll go ahead and stop that. What's also interesting to show is, let's say I'm going to go into a interface and shut it down. So we're going to shut down router 2. We're going to shut its interface down. Right? And what I want to show with that is just what OSPF will do. So show IP OSPF database. So now, as you can see, let me see, sorry, do show IP route. Sorry, show IP route. I want to show you the routing table, and then, right, so now on the routing table, we're able to see that we no longer have the 15.0 network, right? Previously we did, right? Previously we saw on the routing table that we had the 15.0 network, but now as we shut it down, OSPF will go ahead and dynamically update the routing table, and now we no longer have the 10.0 at 15 network within our routing table. right? It dynamically does this. I didn't have to manually go ahead and remove that route. No, it dynamically does this. So I want to go ahead and show just a ping now from router 2, right? So I want to ping the 36.0 network. And I will go into simulation. Go ahead and ping. See, successfully pings that network, right? Because a path, technically the shortest path, right, for the router 2 to reach the 36 network is this way, right? But because this is shut down, it will take this other path, right? It'll dynamically do this. So that's that. But let me go ahead and turn this. Let me go ahead and bring the interface back up. Terminal interface. It shut down, right? And let's go back to router 0. You'll be able to see show IP OSPF. You can see show IP route. See, now the 15 network is there. And then OSPF database, right? So we'll be able to see just its link states, right? All right. Actually, I also want to show you just what is happening right here, how there's messages, OSPF packets, just hello packets just being sent, right? So this is happening pretty continuously, right? Just to make sure that there are no shutdowns. If there are any shutdowns, that that there's link state updates being sent and advertising being sent, so that each router has the most updated link state database. But yeah, this was just me going over what OSPF is. Thank you so much for watching.